Good morning. In this class we wish to discuss the preliminaries of trees. What is tree? A tree is a collection of nodes with the following properties. The collection can be empty. If the collection is not empty, it consists of a distinguished node or called root or zero or more non-empty subtrees T1, T2 and Tk. Each of whose roots are connected with a direct range from R. The root of each subtree is said to be a child of R, and R is the parent of each subtree. If the tree is a collection of n nodes, then it has n-1 edges. And this is the one example. Based on that, we wish to discuss. The node have arbitrary number of children. The nodes B, C, D, E, F, G. These are the childs of A. A is called a root. The nodes with no children are called leaves. B, C, H, I, P, Q, K, L, F, N are leaves. The nodes with the same parent are called siblings. K, L, M are siblings. F is the parent of all of them. What is path? A path from the node n1 to nk is defined as a sequence of nodes n1, n2 up to nk, such that na is the parent of ni plus 1. The length of the path is the number of edges on that path. There is a path of length 0 from every node to itself. There is exactly one path from the root to each node. The path of the node ni is the length of the path from root to node ni. The height of the node ni is the length of the longest path from the node ni to the leaf. If there is a path from n1 to n2, then n1 is ancestor of n2 and n2 is the descendant of n1. If n1 not equal to n2, then n1 is proper ancestor of n2 and n2 is the proper descendant of n1. Then this is the implementation of trees. Already we have discussed that tree has two childs, first child and next sibling. Therefore object is the element, then tree node, first child, then next sibling. Therefore this is the definition of that. Then next we wish to go through that to the tree applications. There are many applications of trees in computer science and engineering. In this first we are telling organization of files in Unix file system. Then indexing large files in database management system. Then compiler design and routing table representation of fast lookups of IP addresses, then search trees for fast access to stored items. Then next we wish to go to the tree traversal. Actually, in this tree traversal, three tree traversal will be there. Free order traversal, post order traversal, next in order traversal. Therefore, one by one we wish to discuss. First, free order traversal. In this traversal method, the root node is visited first, then the left subtree, and finally the right subtree. This is the free order traversal. Therefore, what's the algorithm for that? Until all nodes are traversed, first step, visit root node. We are visiting first root, then recursive travels left subtrees, then recursive travels right subtree. Therefore, we start from A and following free order traversal, we first visit A itself and then move to its left subtree B. Then B is also traversed free order. The process goes until all the nodes are visited. Then the output of the free order traversal is A, then B, then D, then E, then C, F, G. Then this is the result for that. And next, we wish to go through that post-order traversal. In this traversal method, the root node is visited last, hence the name. First travels left subtree, then right subtree, finally the root node. Therefore, the algorithm for that is until all the nodes are traversed, first recursive travels left subtree, then recursive travels right subtree, then visit root node. Therefore, we start from A. First, visit the left subtree B. Left subtree B, first B is also traversed post order. The process goes until all the nodes are visited. The output of the post order traversal is first we are visiting D, then E, then B, after that F, then G, then C, after that you come to the root. This is the post order traversal. Then next we wish to go through that in order traversal. In this traversal method, the first left subtree is visited, then root, and later right subtree is visited. Then the algorithm for that is until all nodes are traversed. First step, recursive travels left subtree, then visit root node, then recursive travel right subtree. We start from A, the following inner traversal. We move to its left subtree B. B is also traversed in order. The process goes on until all the nodes are visited. Output of the inner traversal is first D, then B, then E, then go to the root A, then F, then C, G. This is the output of that. Set it, then now the period traversal post-order traversal and in-order traversal we have discussed. The remaining we wish to discuss in the next class. Thank you.